Welcome all. In previous class, we have discussed identity symmetries and axis of symmetry. So today class we will discuss about of the plane of symmetry. So we are discussing the group theory, and we have discussed in previous class identity symmetries, identity and axis of symmetry. So today class we will discuss about a plane of symmetries, and in next class we will discuss about center of symmetry and improper axis of symmetries. So today class we will discuss about a plane of symmetries. So topic is for today class plane of symmetry. So if we define the plane of symmetry, then it is defined as any imaginary plane of any imaginary plane bisect the molecules in such a way that the two halves or the parts are mirror images of each other. Mirror image of each other. So, if we say the plane of symmetry, it means any imaginary plane that bisect the molecules into two parts such that the two parts are mirror images of each other. Let's say if any molecule, let's say the waters, this is a water, and if I pass any plane means, and this is a plane means any mirror, right? Any mirror, if I pass it like this, then this cut this molecules. This is, let's say this is water, this is H, this is H, this is oxygen. Let's say water is like this. Okay, so this is the water, and any plane I will pass, and it will bisect like this. It will bisect these two parts. Yes, this will be look like this. That will be bisect these two parts like this. Okay, means it will bisect these two parts in the middle, and so that this reflect to this and this reflect to this. And if these are mirror images of each other, then that imaginary plane which we pass, that uh, mirror image, that plane we call as plane of symmetry. Okay, so here if I pass a mirror image like that, so that this reflect to this, let's say this is H1, we'll say H2. After if I pass see, this is represented by, it is represented by sigma. Okay, so if I pass any planes, then this will mirror images of each other. Means this H2 and here will be H1. Similarly, like we have discussed about the axis of symmetry, if I pass any imaginary axis and if I rotate, on the time I am rotating, means this and this exchanging. Now in this plane of symmetry, what they will reflect. So here the operation is, the operation corresponding to this imaginary plane is reflections. For axis of symmetry, the operations is, that is rotation of a molecule from uh, original orientations to equivalent orientations. For that case, that operations is rotations along rotations through any angle theta. But here our operations is reflections. Okay. And in this case, like if we have discussed that if any molecules, like for axis of symmetry, what we say that if principal axis is Cn, then it have n number of C2 that we have discussed. And similarly, and n number of C2 or 0 C2. C2 is present, n number of, otherwise 0 number of C2 is present. We have discussed. In the same case, like that, in case of, this is for axis of symmetry. Axis of symmetry. Cn case. Okay. So similar case for plane of symmetry also, but that if Cn is there, Cn is any principal axis. This is any principal axis. Okay. Any principal axis. What I says that if sigma is present, then n number, n is order order of that axis, and this is highest order, that is called principal axis. So this is the n order, the highest order. So this is the principal axis. So the in case of axis of symmetry, that Cn means how many n order. That's why this is the principal axis. This is highest order. So that same n number of C2 is there. If C2 is present, otherwise no C2, 0 C2 or no C2. Similar case here, if sigma is present, if Cn is the principal axis, sigma is present, then n number of sigma will present. Otherwise, 0 sigma. Okay, so same case like that. Okay, so how many principal axis? Let's say if principal axis is C4, then that 4 number of sigma will be present, or no sigma is present. Okay, like that if C5, then n number of sigma will present, or no sigma is present. Okay, like that in the axis of symmetry, or in case of plane also. Okay, that we have discussed. And we have also discussed that what we have discussed that we have also discussed that in a axis of symmetries, that if Cn, so I will erase this. We have also discussed that if Cn, whatever is the n, the number of operations needed, number of operations needed to get identical orientations orientation is n minus 1. Whatever the n, suppose this is C4, then number of operations needed to get identical orientation is 4 minus 1, that is 3. If this is C8, then number of operations needed to get identical orientation is 8 minus 1, that is 7 operations we needed. Same case for case of that plane of symmetries, that here, unlike this, unlike axis of symmetry, here number of operations needed to get identical orientations is always 1. Okay, always 1. Why? Because this is the mirror image of this. Again, if you do mirror image, then you will get this molecule. So only one operation is needed to get the identical orientations. Okay, so these are the some small things we have to remember. Now, so if we say that any plane, so here also you can pass mirror images. Plane we can pass. Other than that, you can also pass the mirror images like this, which cutting all the uh, hydrogen atoms. So I can pass the plane in two ways mainly. Let's say, this is water. Then one case I was cutting like this plane like this, and other case how I pass the plane which is passing through all the atoms. Means if this is the water, molecules, then one case what I am passing like this, means it cutting only oxygen atoms, After that they are reflecting with each others. Other case, this red line, what I am passing the plane, I am passing like this, which cutting oxygen, hydrogen, all the three molecules. It cuttings. Okay, so I can say the planes, one plane each, this red line, but here the plane passing through or cutting all the atoms in the molecule. So whatever the plane which passing through or cutting all the atoms, whatever in the molecules, all the atoms if it cut, then that type of molecules is called this plane. This plane, which is cutting all the atoms in the molecule, then that plane is called molecular plane because it cut all the atoms in the molecule. It's called molecular plane. Okay. Another this plane is only cutting oxygen atoms, so this is not a molecular plane, this is a molecular plane. Okay, and we can classify that plane into three types. Let's say, so classifications of molecules, classifications of planes. So planes can be classified into three types. One is vertical plane, that is represent as sigma B for vertical, C for plane. Okay. Next type is horizontal plane. Okay, that is plane for sigma and horizontal H. Okay, H for horizontal. Another is dihedral plane. That is sigma D for dihedral. Okay, so three types we can say that we will get in whenever we are discussing about a point groups. We will get three types: CB, CH, CD. So one is vertical plane, another is horizontal plane, another is dihedral planes. And we also remember that molecular plane. Okay, molecular plane means the plane which passing through or cutting all the atoms in the molecules. So this plane is called molecular plane. Okay, now what do you mean by vertical plane? What do you mean by horizontal plane? What do you mean by dihedral plane? It is very important to clear these two planes, these three type of planes. Okay. So let's say that vertical plane. So I simply writing vertical plane, that is sigma B. What is the conditions for the vertical plane. What do you mean by vertical plane? The condition is very very important for vertical plane. What? I'll write simply the condition means you can say this is definition or you can say this is conditions. Or to become a vertical plane, what is the conditions? Okay, so we can take it is also a definition also. So I am writing condition for vertical plane. What? Plane should be or must be, should be. I can write. I can write must be. Plane must be parallel to principal axis. So you know that what do you know principal axis means? Which H? In previous class we have discussed that the axis which H more number of orders means n is highest. That is called principal axis. Or if the same orders there n is same, then the axis which passing through more number of atoms, that is called principal axis. So we have already discussed about a principal axis. So now for vertical plane, condition is plane must be parallel to principal axis. Or also this are you are saying the same thing. We also say in a different words that plane contain principal axis. Okay, this is the only conditions for the vertical plane. Nothing other than that. Only condition is plane must be parallel to principal axis or it should contain the principal axis. Okay. Second case, what do you mean by horizontal plane? Okay, for horizontal plane, that is sigma h. What is the condition? Remember that condition is very very important. Condition is plane must be what? Perpendicular to principal axis. Okay, that is must be perpendicular to principal axis. On that case, that plane is called as horizontal plane or sigma h. Okay, and for dihedral angles, so dihedral plane, that is sigma d. The condition is it should bisect the angle of two C2 axis. Means the plane should bisect the angles of two C2 axis. Okay, so that we will discuss. We will take the examples and we will clear on it. Okay, so this is very very important that for horizontal planes that must be perpendicular to principal axis, and for vertical plane must be parallel to principal axis. Nothing other than that. Only vertical plane means only that is parallel to principal axis, and for the horizontal plane only perpendicular to the principal axis. Only this is the condition. If this condition is satisfied, then that is sigma h. Or if the parallel to principal axis, if this condition is satisfied, on that case that plane is vertical plane. If this condition is satisfied, then that is called dihedral plane. So I will write in the corner this one. We will take examples and look that how this is sigma h, how this is sigma b for different molecules. So I will write sigma b means vertical plane. So I will write vertical plane. What? Plane parallel to principal axis. Sigma h. What? Plane perpendicular to principal axis. Then that plane is called sigma h, and sigma d plane bisects the angle of two C2 axis. Okay, these are the conditions for verticals, horizontals, and dihedral planes. And molecular plane is plane passing through, cutting all the atoms in the molecules. This plane is called molecular plane. Molecular plane only condition is this. Okay, for this. Now, let's take the examples. Let's say water molecules. First, we will discuss about water. Okay. Let's say if I give the names H1 and H2. For although these are same, for identical, I say H1, H2 to distinguish. Okay. So here, what are the planes are present? Okay. So molecular plane means we know which cuts all the atoms. So first I will pass the molecular plane here. This. Okay. And another is, this is also plane. One plane is there which cutting all the atoms. Means if this is the atoms, and if plane pass through all the atoms, oxygen, hydrogen and hydrogen. This is the molecular plane. Another plane also I have, this which planes cut this. Okay. So another planes I have, that is cutting only oxygen and bisect and replace these two. In this case, cut all the atoms and all will reflect. Means molecular plane what happened? That cutting this. So it divided oxygen in two parts, hydrogen two parts, hydrogen two parts. And this hydrogen half will replace with hydrogen other halves. This hydrogen one half replace with other hydrogen halves. This oxygen replace one half with other half of oxygen. For molecular plane. Okay, molecular plane means passing through all the atoms. And another planes, this one. In this case, what this oxygen one half will reflect with other part of oxygen, and this will come here, and this hydrogen is same. So this hydrogen reflected by this, and this hydrogen reflected by this. If I cut the plane like this, okay. So two sigma is present. One is this sigma, another is this sigma. Means these two planes are present, and plane is represented by sigma. Okay. So two sigmas, so two planes I have. Now the question is here, which is we called as here any sigma b is present, or sigma h is present, or sigma d are present or not, we will look. Okay. So for sigma b, condition is plane parallel to principal axis. So in previous class we have already discussed about of the axis of symmetry and plane of symmetry, principal axis of symmetry. So here the principal axis for water is H2. Yes, for this water, principal axis is H2. Principal axis is H2 like this. Sorry, C2. Principal axis is C2. So if I solve in the picture, let's say this is water molecules. This is hydrogen, here oxygen is there. Okay. Now let me say this is the principal axis. Principal axis is passing through like this, and if I rotate, then this will rotate like this. So this is the principal axis. For water, C2 is the principal axis. Okay. Now one plane, that this plane, let's say I say this is sigma, and this is sigma dash. Okay. Let's say sigma dash, this is sigma double dash I take. Okay. So two planes. That sigma dash. So this is principal axis, and this is hydrogen, this is oxygen. Okay. So now if I pass that sigma double dash, that is molecular plane, then molecular plane will pass like this, cutting oxygen, hydrogen like this. So you see these planes and this principal axis are parallel to each other. They are parallel. Okay. So since these are parallel, if this, then they are perpendicular. Okay. These are, but this is cutting all the atom. So all cutting all the atom means this and these are parallel. So if they are parallel to principal axis, then this is not a principal. This is not. This is sigma b. Okay. Other case, other one is, let's say this is the axis, principal axis, and other case I am cutting like this. So if you look at, then this if I passing the plane like this, means this plane will pass like this. Okay. So if I pass like this and this again parallel. So if this again the parallel, then this is also sigma b. Okay. So in water molecules, so we have said that if C2b is the principal axis, then it present either 2 sigma b or no sigma b. So here that principal axis we see, sorry, if C2 is the principal axis, so you say that Cn is principal axis, then n sigma b or no sigma b. So here 2 sigma b is the C2H 2 sigma b. Okay. Similar case. So let's talk about of the PTCl4. PTCl4 2 minus. So if I write PTCl4, here Cl, here Cl, Cl, Cl. Okay. So although this is 2 minus, this one I can write like for understanding Cl, Cl, Cl and Cl. Okay. So in these molecules, we have already discussed in axis of symmetry the principal axis is C4. Here the principal axis is C4. How C4? We have already discussed. Let's search. Okay, principal axis C4, that is passing through like this. And what are the planes are present here? So one plane is if the molecule is planar, then always molecular plane is present. So this is also planar, means molecular molecular plane is present. So first is molecular plane like this. Okay, let's say this is sigma b, one molecular plane, and other planes also you can see that plane passing through like this, only cutting PT. So this is also one molecular plane. Let's say sigma b dash, and other molecular plane also present here. Let's say if I pass like this is also sigma b double dash. This is also there, and other is also there. Let's say if passing through like this is also there, and other also like this. So how many planes we pass here? One. This is one molecular plane. 1, 2, 3, 4, 5. So total 5 planes we have passed. So now we want to know that which is plane, which is CB, which is CH, which is CD from here. So we will discuss which is CB, which is CH, and which is CD. So for CB, the condition is parallel to principal axis. Okay. So how it will look? Let's search. And principal axis is C4 here. Okay. So everything will done with respect to principal axis for this case. Okay, with respect to principal axis. So let's search this case. This is a planar molecule PTCl4. So let's search this. Okay, so let's say this is the planar molecules. Now that C4 is like this direction. C4 is here. Okay, this is principal axis. So if you rotate it, then it will rotate like this. If you rotate like this. Okay, so this is the principal axis. Now the planes which is uh, parallel to principal axis, that are CV. So in this directions, so let's say this is the, I take the mirror. Plane means any mirror, any imaginary plane or any mirror I take. Okay, so mirror or plane is same because it will also reflect. For the plane, that should be reflect. So I take plane as a mirror here. So let's search this one. So if I pass that, for CB, condition is plane parallel to principal axis. So this, the plane should be parallel to this. This is the principal axis. So this should be, plane should be parallel to principal axis. So if I cut like this, yes, if I cut like this, then this is my plane and this principal axis are parallel. So this is, so this planes is CB because this is parallel to principal axis. And other case, if I search that, like this is our principal axis for C4. Okay, for this case, this is the principal axis. So now, is there sigma h is present or not? How can you look? That should be perpendicular to principal axis. So if a plane which cut all the atoms and first like this, then this plane is perpendicular to this. So this axis, which is uh, molecular plane here, this CB is perpendicular to principal axis because principal axis is coming like this and this is cutting all the atoms. So this is here the horizontal plane, sigma h. Okay. So here the molecular plane is become the horizontal plane. But here the molecular plane was not horizontal plane. That case here vertical plane. Okay. And like this, if this is the our vertical plane, this is our principal axis, then if I cut like this is also parallel to principal axis, and this is and this which is cutting all the atoms here, this is the perpendicular to sigma h, so this is sigma h. So if I cut like this is also parallel to principal axis, and if I cut like this, then also parallel to principal axis. If I cut like this, or if I cut like this, or if I cut like this, all are parallel to principal axis. So here only this is uh, uh, horizontal plane, rest all are vertical plane. So all are vertical plane. So previously also I have written. So these all are vertical plane. Okay. So what you get here, that I will remove this molecular plane. Molecular plane. Here the molecular plane is sigma h, horizontal plane. Here the molecular plane is vertical plane. So molecular plane, it can be uh, sigma b or sigma h. Okay, so molecular plane, there is no condition, it can be sigma b or it can be sigma h, and sigma h is always perpendicular to principal axis and sigma b is always parallel to principal axis. But molecular plane, it can be sigma b or it can be sigma h. Okay, so like here sigma b for water and sigma h for PTCl4. Okay, so we'll take more examples. let's say if I take about of the ammonia, and also we note one thing that a sigma H present, if sigma H is if present, then only one sigma H, we get, or no sigma H. But sigma B, which the sigma H is, we know that if Cn, then if sigma B is present, then n number of sigma B is present, or no sigma B is present. For sigma H, if present, then only one sigma H is present, otherwise no sigma H is present. Okay. Now we will take another examples, that is, let's say that ammonia. So it will look like this. H. So in case of ammonia, the principal axis is, we have discussed, principal axis is C3, and here the ammonia, how it will look like. So ammonia H look like this. So in previous class we have discussed that this is not a planar molecules, that we have discussed, due to its lone pair, its planarity will vanish and it is look like this. So one is plane, one is above, one is below. Okay. So here that principal axis is here in this sides, this is CT, so if you rotate, then it will rotate. So this is principal axis. Okay. So now if I cut one planes, that cutting this is the planar, this is above, this is below. If I cut like this, then this will reflect on this. Okay. So one sigma B we get. Another case, if I rotate like this little bit, any rotation, the rotation is independent, and if I cut like this, then this reflect this. Okay. So here what we say that C3 and one sigma B we get, then you know that Cn, if one sigma B you get, then we get the 3 sigma B, sorry, n sigma B, here principal axis is C3, so C3, then if one sigma B we get, then there must be 3 sigma B. Okay. So here 3 sigma B is present here. One is like this, another is like this, another is like this. So sigma B dash, sigma B double dash. So 3 sigma B is present in case of ammonia. So here that whether sigma H or sigma, so why this is sigma B, why not this sigma H? Let's say H. This is the molecules, and this is the principal axis. Okay. So if I cut these molecules, then if I cut here, then this and this is the principal axis and this is the plane. So this and this are parallel. So parallel means sigma B. Here also this and this are parallel. Here also this and this parallel. For getting sigma H, I need one plane like that, so that this and this perpendicular. So if I pass this plane like this, then this will reflect here, but here no atoms. Here no atom. Here no atom. If I pass the plane, then this will reflected above, this will reflected above, this reflected above, but no atoms is there in above, so sigma H is not present. So if sigma H is not present, all are sigma B. Okay. So frequently sigma H and sigma B is used. Sigma D is very less used. So it is very important to clear about of sigma B and sigma H. Okay. Now another case we will discuss, that is if he says that SF6, if you discuss about of that SF6, so SF6 of this S, F, F, F and F. One is F. Okay, this is the SF6 molecules. Here what happened that two molecules will be like this, and one is like this. And one will be above, one will be below, and principal axis is C for So if the plane passing through these four atoms, here molecular plane is not there because this is not a planar molecules, because the one is above and the other is below. So one, the plane which is passing through all the four atoms plane, this is principal axis C4, and one atom is here, other atom is also here. Okay, one atom is above, one atom is below, and principal axis also this side. Okay, this is principal axis. So the plane which is passing through this will be perpendicular to principal axis. So here sigma h is present, and also we can cut here also, because one is above, other is below is there. So another, if you cut like this, passing through below and above, and if you cut with these two, then also that, but that is parallel to principal axis, then that all are sigma b. Okay, let's say one plane, that is plane passing through like this. So this is and C4 is like this. So this is perpendicular to principal axis. So this is sigma s. And others are like this. They are cutting like this. So they are not perpendicular to principal axis, because if I say this and this, okay, and this is our principal axis. And if I cut like this, then these are parallel to principal axis. These things. Okay, so that's why these are sigma b. Only this plane is sigma h. So only sigma h is only one sigma h, otherwise no sigma h. Sigma b, if one sigma b, then here principal axis is C4. So how many sigma b will be present? 4 sigma b, because sigma b is n number of sigma b. Okay. So here sigma h is present, here sigma h is not present. Okay, because in the whenever you pass the plane, then above is nothing is present, and principal axis also like this. So here if you have plane, then they are perpendicular with principal axis. On that case, sigma h may present, but here this plane is not present. That's why in ammonia sigma h is absent. Now we'll discuss about of the dihedral plane. Okay. Now we'll discuss about of the dihedral plane. So dihedral plane, what is say that plane bisect the angle of two C2 axes. Let's say about of PTCl4. Okay. So in this case, although this is like this, but I will draw for understanding. So in this case, in this molecules, what we see that one planes I can pass, one plane I can pass. So what the plane bisect the angle of two C2 axes. So C2 axis is, let's say here I can pass one C2 axis. Here is the C2. So here if I rotate, then this will this. If I rotate, then this and this will, let's say here this is the molecules. So if I pass the planes which cut this, and if I rotate, then this will, this and this get replaced. So let's say this is C1 and this C2, and if I apply C2, then what it will become? PT. This will CL remain, then this will become C1, this will become C2. So I can pass one C2 here, and I will not pass C2 here. Let me pass the C2 from here. Okay. If I pass C2 by here, then this get reflected by this replaced by this replaced by this. Okay, this is one C2. Another C2 I can pass this directions. This is another C2. This get reflected, this get reflected. So here this by this, another this by this. So this is the angle. So this angle is bisected by any oh yes, this is axis. So other way this also fine, but first we will discuss about the what we have written in the definitions. PT, CL, 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 CL. So what we says that one plane bisect the two C2 axis. Okay, so this is, let's say, one C2 axis and this is one C2 axis. So in between of this and this C2 axis, this is the angle. So I will pass a plane which bisect the angle of two C2 axis. So this is the angle of this two C2 axis. So I will pass one plane which bisect this angle. So this plane is called dihedral planes. Okay. Also this way, in other way also we can say that if PT CL 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 CL, and now what I says that I will pass two planes. One plane is like this, then this get reflected, other planes like this, then this axis, this is this C2 axis, then these two planes are this set of planes are dihedral planes, or you can say PT CL 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 CL, and what I pass one plane here